Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. Log models with interactions, we've seen quite a few videos and different interpretations, while all of them are looking at one formula. So in this video, we're just going to do a quick recap of all the different models and how the interpretation distinguishes so that you don't get confused with one another. So keep in mind, we've covered log level with interaction, log log, and level log with interaction. In every case, the marginal effect that you have seen has been beta 1 plus beta 3 z, and the formula never changed. What changed was what the formula measured depending on which variables are logged. Okay, so you master the formula once, then just ask, what are x and y in my model, and you will have the answer right away. This little table in here is a bit of a summary of all the three different models, what varies in each model, and the interpretation of the beta 1 and beta 3. So you can have that as a summary going forward in case you need to look at again for the interpretations that you need to make. So for the log level model, you have percentage effect of unit change in x, because for the first model, you had the derivative of ln of y with respect to x. Okay, so your interpretation went 1 unit increase in x changes y by approximately beta 1 plus beta 3 z percentage, like time 100%. Okay, the percentage effect of a unit change in x varies with z, and this is also the most common starting point for applied researchers with log, who log their dependent variable. And I'll just make a little adjustment in here, as it seems I have forgotten the times 100 in here for the percentage. The second case for the log model, keep in mind your partial derivative in here would have been ln of y with respect to ln of x, and the formula again would have given you beta 1 plus beta 3z, but the interpretation would have been in terms of elasticities, so a 1% increase in x changes y by beta 1 plus beta 3z percent. The last case, the level log, the derivative, the partial derivative would have been the derivative of y with respect to ln x, again beta 1 plus beta 3z, but the interpretation would have been a 1% increase in x changes y by beta 1 plus beta 3z divided by 100 units. Okay, so this was less common in practice, but the interpretation logic is identical. So same formula, different interpretation. Just make sure you always know which of the variables are logged. A common thread that you can see through all of these models is that in every case that we saw worked examples on, the beta 1 is the effect when you had a z equal to 0. And then otherwise, beta 3 is the rate at which the effect changes with z, and then beta 1 plus beta 3z is the full marginal effect. Okay, so this is exactly the same structure as the linear interaction model case as well. Log models just add percentage interpretation, but the interaction logic is identical. So in log interaction models, the formula beta 1 plus beta 3z always gives a marginal effect. What changes is simply how you interpret it. I hope this was helpful, and I'll see you in the next video.